All right, so 6.6, it says special quadrilaterals. This is all of the types of quadrilaterals that we've talked about in the past 5 sections. So basically all we're doing is taking all of that information that we've learned and we're putting it all together, okay? So in other words, we went through a couple sections where we looked at just parallelograms. And then we looked at a section where we just looked at rectangles, rhombuses, and squares. Then we looked at a section where we just looked at kites and trapezoids. This section says put everything together, okay? So don't just assume that we're looking at kites and trapezoids and answer your question. Assume we're looking at everything, okay? So example 1, you need to tell me what kind of quadrilaterals meet the given condition. So condition 1 says ABCD has at least 2 congruent consecutive sides. So you need to list any quadrilateral that has at least, and that's kind of a keyword, at least 2 congruent consecutive sides. Who can name at least one for one quadrilateral that would meet that condition? A square. It actually has all 4 sides are congruent, right? But it does meet that description that says at least 1 pair of consecutive sides are congruent. Okay, what else would also meet this condition? A rhombus, yep. So a rhombus is similar to the square, where it has all of the sides are congruent, so of course you have at least 1 consecutive side that's congruent, right? What else is guaranteed to fit this description? At least one pair of consecutive congruent sides. Manasa? A kite has at least 1 pair. It actually has 2 pairs, right? But it does fit that at least 1 pair. Okay, think to yourself, is there anything else? So the other types of figures we know are just, would a regular old parallelogram necessarily have congruent consecutive sides? No. A regular parallelogram would have congruent opposite sides, but not necessarily consecutive sides. How about rectangle? Not necessarily. And a trapezoid? Not necessarily. Okay? So let's look at B. The diagonals of RSTQ are perpendicular. Which quadrilaterals meet this condition? So think to yourself, what quadrilaterals do you know that have to have perpendicular diagonals? So the rhombus was the very first one that we learned that had perpendicular diagonals. And then you have to remember that since a square is a type of a rhombus, it would also have the perpendicular diagonals. Is there any more? What was that? The kite has perpendicular diagonals. That was something that we learned in the last section. So just kind of coincidence that both A and B had the exact same set. But basically, I'm just asking you guys to put together all of the properties that you know and be aware of everything that matches every property, right? Okay, so this was a basic question. They will get more tricky. So in example 2, it says, when you join the midpoints of the sides of an isosceles trapezoid in order, what special quadrilateral is formed and why? So are you guys just going to think about it, or what are you kind of tempted to do right now? Draw a picture, probably, right? So you're going to sketch something that looks like an isosceles trapezoid. That's where I would start. And do the best you can. My isosceles trapezoids sometimes don't look that isosceles, but doing the best we can. Right? And it says to join the midpoints of the sides. So basically what we're looking to do is find all of the midpoints of the sides. Like that. Oops, and that's not quite close enough. And then it says to connect them in order, going around. So if I connected them in order, okay, now what is your instinct telling you right now? What does it look like? Looks kind of like a rhombus, right? But it says to say, in bold and underlined, the most important part of this question is, why are you sure that it's a rhombus, right? Okay, so there's a couple of different things that you have to show me. What properties, think to yourself, what properties do you know about a rhombus? Sides are all equal, right? Perpendicular diagonals, right? So let's start there. Let's draw in the diagonals and see, are you convinced that they would be perpendicular? Are you convinced that those should be perpendicular? I am, yeah. So when you draw, the midpoints of the top and the bottom of an isosceles triangle are going to be directly on top of each other, right? And then we already know that this line right here, it's a mid-segment of a trapezoid, and it should be parallel to the top and the bottom. And so we're assuming that these are perpendicular. Okay, but how do I know it's not a kite? Because a kite also has perpendicular diagonals. What other property do you know about, what was that? Okay, we could show that all sides are equal. Slopes could be parallel, but I'm not on a coordinate plane, so that's going to be kind of hard to show. How about, what's the difference between a kite and a rhombus? One of them is a parallelogram, and one of them is not, right? Okay. How can you show that something's a parallelogram using the diagonals? What do you know about any diagonals in any parallelogram that's not true for a non-parallelogram? They bisect each other. Okay, so let's kind of think about that. We've already just talked through that. We're pretty convinced that, well, we're not convinced. We know that this is a right angle. So we know that they're perpendicular, right? What I now need to show is that they bisect each other. Because if they bisect each other, then it matches the definition of a parallelogram as well. And that would force it to be a rhombus instead of a kite. Okay? Do you agree when I put these marks in? With an is that going to be true for a non-isosceles trapezoid, though? Not necessarily for a non-isosceles, right? We have a perfect symmetry in this isosceles trapezoid. That's why we get this, is that an isosceles trapezoid, you fold it down this line, and it will match perfectly on the other side. So yes, these two lines would bisect each other. Do you think that these two bisect each other? Yes, and the reason why is because you have cut a trapezoid perfectly in half, right? These are the midpoints right here, so you're cutting it horizontally in half. Okay, so your reasoning would be that this is a rhombus. Oops. And when it says why, you would have to explain because the diagonals bisect each other. Which means, what did that tell us? When they bisected each other, that told us it was a, I kind of did this, I switched it up on you guys. I'm talking about the bisecting, which means that it's a, in general, parallelogram. And then that's when I'm going to bring in the diagonals are perpendicular, and that tells me that it is a rhombus. Right? Yes. Potentially, but not always. It would just have to be that perfect stretch this way to force it into a square. but it's not always going to be a square. Okay. Any other questions? Okay. So example 3 says in a quadrilateral RSTV, angle R is 88 degrees, and then angles S and V are 113. What type of quadrilateral could RSTV be? And must it be this type? Okay, so I just heard Kayla and Eddie over here saying that it's a kite because S and V are equal. Okay? Why does that lead you to think it's a kite? What kind of angles are S and V in relation to each other? Are they consecutive or are they opposite? And how do you know? And how do you know? Right, so they're looking at this RSTV and they know that that goes around the figure in order. So it would go R and then S and then T and then V around the figure, which means that angle T is in between S and V, which forces S and V to be opposite of each other, right? So you have one pair of opposite sides that are equal, but how do you know it's not a parallelogram? What if R and T are also equal? Do you have enough information to know if those are equal? How can you figure that out? Right, so you can add them all up and subtract them from 360 and see if that last angle equals 88. You can also, and let me just kind of talk you through this, parallelograms, what's the relationship between consecutive angles and parallelograms? They should add up to 180. So rather than finding that last angle, couldn't you take 88 and add it to 113 and see if they add up to 180? And if they don't, then it can't be a parallelogram, right? So let's kind of reason through this really quickly. When I'm writing up my explanation, I'm first going to notice that S and V are congruent opposite angles. Okay, but then I'm going to point out that S and T, or S and R, are consecutive angles that add to what? So what's 88 plus 113? $201. So are they supplementary? Right, so we would say, so S and R are not supplementary. Which means that this is not a what? What were we checking there? A kite doesn't have to have both supplementary consecutive angles. So remember, we were talking about when we brought up the supplementary consecutive angles, I asked you, why couldn't this be a parallelogram, right? That was kind of the motivation behind that question. So when we check that consecutive angles are not supplementary, it means that RSTV is not a parallelogram, right? Yeah, and that's kind of why I was saying you need to do the check to make sure that it's not a parallelogram. Because when you said, oh, those opposite angles are equal, I asked, well, couldn't it still be a parallelogram if one pair of opposite angles are equal? So you had to check the other ones, right? So at this point we say, so with one pair of opposite sides or opposite angles, RSTV could be a kite. All right. I think we've got one more example for today. We're going to do the other examples tomorrow. All right, so for example 4, it says the diagonals of ABCD intersect at a point N to form 4 congruent isosceles triangles, A and B, C and B, C and D, and A and D. All right, I'm just going to really quickly sketch something up. Don't follow this yet. I'm going to draw something and I want you to kind of analyze it. So basically, when you draw any quadrilateral, any old quadrilateral, and you draw their diagonals, okay? And they say that A and B, C and B, C and D, and A and D, and I'm not going to put the letters around it yet, but basically what they're saying is that these 4 triangles that are formed off of the diagonals, they're saying that those have to be all congruent in all isosceles, right? Okay, so let me draw something else. Would you agree that this is an isosceles triangle right here? And is this an isosceles triangle? Why is this drawing still not okay for this description? Because they're not all congruent, right? These wider isosceles triangles are not the same as these kind of thinner isosceles triangles, right? So I need them all to be congruent, which means what do I know about all of the angles around the center? They all have to be... How do you have them all be congruent? As if they're all right angles, right? So that's kind of your starting point right now. I'm kind of trying to get you through understanding like why this one wasn't quite good enough, because the triangles weren't isosceles. Now I've given you isosceles triangles, but they're not all congruent. So what do? You instead force them to be perpendicular diagonals, and also keep in mind that you still need the sides to be congruent. So what kind of a shape is going to give you perpendicular diagonals and congruent diagonals? A square. So let's draw that real quick and see if it matches everything that we need. Okay, so if I draw a square and I draw my diagonals, does that give me 4 isosceles congruent triangles around the center? That's the question. And the answer is yes, and you can see it because you've got right angles in each of these because they're perpendicular. And since it's a square, you get the rectangle property that all of the diagonals are the same pieces. So every single isosceles triangle has this same side angle side congruence, which we know from way back when. Side angle side is a congruence relation that will guarantee congruent triangles, right? All right, we're going to leave off on this example today and then pick up on the rest tomorrow. No homework tonight. That'll be tomorrow.